All right, let's take a look at President Garfield's favorite trapezoid question. So we want to find the area of this trapezoid. And we're not given the height, so let's draw the height in by dropping a perpendicular from A. And what we have done with most of these isosceles trapezoids is drop two altitudes, creating a rectangle and two congruent triangles. But in this case, I do not have two congruent triangles. The heights are equal, but since in the two triangles the hypotenuses are not equal, the two triangular sections aren't equal. So if the length from D to this altitude is x, this length from the altitude to C is not x. But we know that if we drop this 10 down, we know that this section plus this section has to be 14. So if we call this small section x, then this section over here can be described as 14 minus x. That's true. Now, as we talked about Friday, if you see two variables, you should immediately be thinking about trying to find two distinct equations. So from this triangle over here to the left, let's call it triangle ADE. Triangle ADE, I see that I have x squared plus h squared equals 13 squared, or x squared plus h squared equals 169. On the right-hand triangle, if we call this BFC, this triangle over here, I have h squared plus 14 minus x quantity squared equals 15 squared. H squared plus, all right, I need to expand 14 minus x, and I get 196 minus 28x plus x squared equals 225. You can always take this over to the side and FOIL it, right? Two separate binomials, and then FOIL it for your expansion. All right, so many ways to solve this. What I'm going to do over here is solve for h squared. So h squared would be 169 minus x squared. So I can take this 169 minus x squared and substitute it in for the h squared. And I would have 169 minus x squared plus 196 minus 28x plus x squared equals 225. Negative x squared, positive x squared, those drop out. If I were to add 169 and 196 right here, I would get 365. So I would have 365 minus 28x equals 225. Subtract 365 from both sides. Divide by negative 28, and this works out really nice. X is 5. So we know that the area formula for a trapezoid is 1/2 height, base 1 plus base 2. So even though I have x, I still need to find h. So I can plug this 5 into my formula that says 5 squared plus h squared equals 13 squared. Or hopefully some of you recognize that that's a Pythagorean triple. So I'm going to get 12 for h. And the area is going to be 1/2 of the height, the sum of the bases, half of 12, 10 plus 24, or 6 times 34 is 204. No units, I don't have to worry about that. Remember, this is President Garfield's favorite trapezoid question.